Hi everyone, welcome back. We are going to do some more with area today. Two different things actually with area. The first thing we're going to talk about is how to find the area of irregular figures. What that means is basically you have a shape that's not a typical shape that we've learned. So in the last lesson we talked about rectangles, squares, triangles, trapezoids, and how we found the area of those given a formula. Well, in the shapes that we look at today, they're not any of those shapes. And so what we have to do is we kind of have to divide them up and make them into shapes we know how to find the area of. Okay, so I had mentioned in the last lesson also about having to find the area of my porch floor so that I could retile it. And this is exactly what I had to do because in the first example, my floor kind of has that same shape. And so it's not possible to just find the area of the entire thing at once because it's not a regular shape. So what you have to do to find the area of these is you're going to split them up into shapes you know how to find the area of. Okay, so in number one, I might take this shape and I might go like this. I might split it up so that it's actually two rectangles that I have to find the area of. And what I can do is I can then take those two areas and add them together to get the total area. Okay? So the trickiest part about this is going to be finding the sides that you don't know the length of. Okay, so there's some missing sides here that we have to figure out. But let's look at the rectangle on the left to start. So what I need to find the area of any rectangle is the length and width. And so I have to look at that rectangle and think, okay, what is the length and what is the width? Well, the easiest thing you probably can spot is that this side right here is our width. Okay, it shows you right away that that's 11 feet. Now to find the length, I'm kind of debating between using the 12 and the 17. But I can see that this 17 feet represents the length of that entire shape. And so I don't want to use it when I'm just trying to find the area of this little rectangle. I'm going to use the 12 because the 12 represents the length of just that rectangle. So I'm going to start with 11 times 12. That will give me the area of that rectangle. And 11 times 12 is 132, and this is feet squared. So I'm just going to label that in my picture just so we can keep track of what we've figured out so far. Okay, so now what I need to do is I need to find the area of the other rectangle. I'm just going to change my color here so you guys can see. So in order to figure out the area of this rectangle, again, I need the length and the width. So here is my width, and here is my length. Now, unfortunately, neither of those sides is labeled, and so I really need to do some work to figure this out, okay? One way that I could look at finding the width is to say, okay, I knew this whole side was 17, and I know this side is 12. So 12 plus what is going to give me 17? 12 plus 5. So I know that that width would have to be 5. Now, to find the length, I would look at the other side here and I would say, okay, this was 11 and this is 1. So 11 plus 1 would give me 12 feet. So now that I have both the length and the width, I can go ahead and multiply them and get that that area is 60. Okay, so the last step is to add the two areas together. So 132 plus 60 would give me a total area of 192 feet squared. Okay, so again, you're taking it, you're splitting it into two shapes that you know how to find the area of, and then you're adding the two areas together. All right, so let's try another one over here. So let's break this shape into two shapes we know. So again, I might go like this and say, okay, I can do two rectangles again. So I'm going to start with the rectangle on the left. Now I can see right away my width is 1. What I don't know is what is the length of that rectangle. Okay, so this 14 that's shown here, that's the length of the entire shape. So I don't want to use 14. And I also know that this, from here to here, is 10. So wouldn't it make sense that this would have to be 4? Because 4 plus 10 would give me that total length of 14. All right, so my length times my width gives me an area of 4 for this little rectangle here. Okay, so let's go ahead and do the bigger rectangle. Now on this rectangle, I already know the length is 10, and thankfully I also know the width. It's 2. So 10 times 2 gives me 20 square inches. Okay, so to find the total area, I'm going to add the smaller rectangle plus the larger rectangle to get 24 square inches. All right, let's do a couple more like that. So we have in number 3, a shape that you might want to consider splitting up into more than 2 shapes. Okay, so if I were to pick, I would split it up like this, and I would make it into 3 rectangles. Okay, so I'm going to start with this rectangle on the left. That seems like a good one to start with because I can see here is the length and here is the width. Okay, so the length is 12 and the width is 10. And so the area of that rectangle is 120 centimeters squared. Okay. Let's try the middle rectangle. So in the middle, this is my length and this is my width. Okay, so really I know nothing. So we got to figure this out. Now, what I do know is that the entire length of this figure is 24. And I also know that this side plus this side plus my missing side needs to equal 24. So if I add 10 plus 3, that's 13, and then I subtract 24 minus 13, I'm going to get that my missing side right here is 11 centimeters. Okay, so that's how I would get that side. Now the other one I'm missing, this side right here, I would have to look and say, well, if this whole side is 12, and I know this little side is 9, 9 plus what has to give me 12? And I would know that that's 3. Okay, so my middle rectangle here is 11 times 3, which is 33. Okay, now my very last one on the end here, I'm going to have to do length times width again. And let's see, we already know the width is 3, so that's helpful. But I don't know the length. But I can figure out the length because it should be the same as this side over here, which we already know is 12. Okay, so we can say 12 times 3 is my area, so 36 centimeters squared. Okay, so now that we know all 3 areas, to find the total area, we add them together. So 120 plus 33 plus 36 gives me a total area of 189 centimeters squared. Okay. All right, let's take a look at number 4. So this one again might be a good one to split into 3 shapes. I would say we could go like this. Okay, so if we look at the top rectangle, start with our formula here, length times width, I can see that the length of that rectangle is 9 and the width is 2. So that's a good one to start with, 9 times 2. All right, so that gives me 18 meters squared for that top one. For the middle one, so this is kind of interesting. Let me change my pen here. You guys can see that this right here and this right here and this right here, those are symbols that show equality in length. So if this is 2 meters and it has that little mark, that means that this is also 2 meters. So I actually know the length or the width of that rectangle. And so what I need to know is I need to know what this length is. Okay, so if I know that this entire side is 9, and I know that this is 3 and this is 3, this missing side here has to be whatever 3 plus 3 subtracted from 9 is. Okay, because those 3 things together need to make 9. Well, 3 plus 3 is 6, and 6 from 9 is 3. So that side must be 3. So now I know the length and width of that rectangle. So I can say 3 times 2 is 6 meters squared. So that in the middle there is 6. All right, and then I'm going to go back and do this last one, which is the bottom, which length is right here times width, which is right there. So even though I don't actually have those labeled as what they're supposed to be, again, this mark right here means it's the same as the other 2 sides with that mark. So I know this is 2 meters. And then the length is actually going to be the same as that top length, which we knew was 9. So that bottom rectangle is the same exact size as the rectangle on the top. So 18 meters squared. Okay, so to get our total area, we're just going to add those together. So 18 plus 6 plus 18 is going to give me, what's that, 36 plus 6, 42 meters squared. Okay. All right, so we have 3 more like that, and what I would recommend you doing is I would pause the video here and I would see if you can get the answer right for number 5, and then play it, see if you got it. If you didn't, you can listen to how I explain it, and then I would pause it again and try number 6 and see if you get it, and so on for the next 3. I think that would be really good practice. Okay, so go ahead and pause it. All right, so if you've done those, I am going to show you how I completed them. So I decided to split my shape into 2 rectangles that look like that. And I was able to see that the length and width are 6 and 4. So I knew that that rectangle had an area of 24 square yards. Okay, and then for the other rectangle, I could see the width was 2, but in order to get the length here, I had to realize that this entire thing was 10, and this was 6, and so 6 plus what gives me 10? This would have had to be 4. So for my other rectangle, my length times my width was 4 times 2, which is 8. Okay, so to get my total, I would have added 24 plus 8 to get 32 yards squared. Now you could have also cut this completely different and gotten the same area. Your work just would have looked a little different. Okay, so there are different ways to find that same area. All right, so I would pause the video again here for number 6. Go ahead and try it and then press play. Okay, so for number 6, I decided to cut it this way because I thought that would be easiest for me. And so I'm going to actually start with this big rectangle because I can see 11 is my width and 12 is my length. So I would do 12 times 11, and I would get that is 132 meters squared. Then I have this little rectangle up at the top here. So I know the width of it is 1, but what I don't know is this right here. So since I know this whole side is 12, and I know this side's 11, 11 plus something has to give me 12, which is 1. So that's actually a square right there. So you could have done 1 squared or 1 times 1. Either way, that little area is 1 square meter. Okay, so again, to get my total area, I'm going to add 132 plus 1 to get 133 meters squared. Okay, last one to try on your own. Go ahead and pause the video. Okay, so for this one, hopefully you cut this into 3 different parts. Okay, so I'm going to start with that top rectangle. I'm going to say this is my length, 35, and my width is 9. So 35 times 9 gave me 315 millimeters squared. Then I'm going to look at that middle rectangle. So this would be my length, and this would be my width. Now, I don't know either of these, so let's figure this out. We know 38 is the entire length, and I know there's a 9 and a 15, and so I have to figure out what's the missing side here. 9 plus 15 plus what gives me 38? Well, 9 plus 15 is 24, and 24 plus 14 would give me 38. So I know that that has to be 14 millimeters. Okay? In order to get the other side that I need, I'm going to have to think, well, if this whole thing is 35, okay, and this is 20, what does this have to be to equal 35? So 20 plus what gives me 35? And that would be 15. Okay, so now I have the length and width of that middle rectangle. 15 times 14, which is going to give me 210. So this is 210. Okay, and then I have one more rectangle at the bottom. And let's see, I can see the width is 15. That's helpful. And the length I can actually see is the same as the length on the top, which was 35. So that last rectangle is going to be 35 times 15. And that is 525. 525. I forgot to write this was 315. Okay, so we are going to add those 3 areas together. 315 plus 210 plus 525 to get a total area of 1,050 millimeters squared. Okay, so our last topic here is to find shaded area. And to find shaded area, we basically think about this as taking a shape and cutting a shape out of it. Okay, so if you think about number 1, we have this big square here, and what's happening is I'm cutting out of the middle a little square. And so I'm taking that big square's area and I'm subtracting the little square's area. Okay, so we can see it's a square because they show us that the side lengths are the same. That's what those tick marks mean. So I'm going to start with my area of a square formula. And then I'm going to say, okay, each side of the square is 8, so 8 squared. And that's going to give me 64 meters squared. So that's the area of the big square. Now I'm going to cut out the little square in the middle. And so again, I'm going to use side squared. And since each side of that square is 3, that means that my area is 9. Okay, so you're thinking of this as taking the area of that big square and subtracting the area of the little square. And what that does is it leaves you with that shaded area. So 64 minus 9 gives me a shaded area of 55 meters squared. Okay? All right, last one here. Again, I'm taking this parallelogram and I'm cutting out a circle in the middle of it. Okay, so what we have to find first is the area of the parallelogram. And to find the area of a parallelogram, we do base times height. So the base of the parallelogram is 12.1, and the height of the parallelogram just happens to be the same as the diameter of that circle, so times 6. And that's going to give me 72.6 centimeters squared. Okay, so now I am going to take the area of that circle and I'm going to subtract it away. So we did area of a circle in our last unit. The area of a circle is pi r squared, and it tells us to use 3.14 for pi, so we need to make sure that's what we're typing or putting in there. And 6 is considered the diameter of my circle, so the radius is half of that, which is 3. So 3.14 times 3 squared, or 3.14 times 9. That gives me 28.26 centimeters squared. Okay, so again, the reason we're subtracting now is because we take the parallelogram's area and we cut out that circle that's in the middle, and it leaves us with the gray area, what's left behind after I cut that circle out. And that's 44.34 centimeters squared.